Today we're going to talk about a new discovery and actually a better way of building software and system in this case. And we call it Fayad Unified Software Engines, fuses, are here to stay. System and application software are out completely. So we're going to talk about this. We're going to kind of give some ideas how we're going to do this as a first introductory to fuse. This is, a way to build better systems. This is again, go on to, we're going to use this presentation, and all the presentation I'm going to do is going to be like a scary movie. So we're going to introduce a scare, which is actually general state of panic, identify the killers or the problems, catch the killers, the solution. Now we're going to talk about the first stage here, which is actually would be the scare, which is your general state of panic. So let me. We build software and system and software application business as usual, which is a problem, big problem. This is again just some idea to give you how deeper we are. We spend a lot of money on different software system, but we're actually losing it. Do you know how many soft system or software application in the world? This is millions, more than millions, by the way. There is no enough estimate to do that, but this is very close. All the existing software and system application are legacy system, where this has become a big problem. Why? Because again, in this legacy system, maintenance become a nightmare. And we have to keep maintaining the system until we get rid of it. So we waste money to develop it. We can kind of waste money to keep maintaining it. And this is, by the way, this is a loss of billions of dollars every year. They estimate almost $5 billion in the United States alone, by the way. So now, system and software programs vicious, disastrous problems, by the way, within the software. Corrupted system software applications such as financial, media, credit, military, keep going, all of them, Now, we have one big problem, the hardware dependencies. So, hardware dependency, we have to get rid of it. Now, the people on hardware, they usually indicate the most important thing is the hardware, but this hardware cannot do anything without software. Now, we have to have a way for making software independent. Why? From the hardware. Because we need to advance in software. We're not building enough in software, by the way. We you could really imagine the amount of software we built is like a small, small river. But again, you see, when the ocean still exists, we still have a lot of applications to explore and to build, because any system cannot work without software. We wasted billions of dollars on canceled software projects, re-engineering the wheels, which is actually inventing the wheels, maintenance nightmare, and actually cybercrime, no privacy. If anybody told you software had privacy, no way. They fool you. There is no privacy in software. This is actually, get this clear in your mind. There is a lot of things we talk about software, like, for example, reliability. There is no reliable software. Now, I don't want to tell you scary stories about some of the existing software. If you know, you would never just use it, period. So let's identify the killers. Now, we have an alternative here, which is we have to do it, which is fuse. Now, captures the art and science of and engineering of the engine. The engine, as you know, is a bunch of unified words, no concepts. This is again very important because the word is a cornerstone of any system we build, not concepts. Concept is a disaster. Concepts are disastrous. Sorry. So this is going to kind of give us debatable for the long time, not exist in current software engineering, unfortunately. This is brand new. Nobody done that. Even the engine exists right now. They're not built by the process we're doing, and actually the methodology, the tools, and all the stuff. Fuse is a system of patterns. This is the first time we're putting a very important big systems into a system of patterns. Was a slogan, was used in design patterns, the Gango 4, the Siemens, and all the patterns exist. They could not do it. And I will tell you why. This is not a problem then, because again, patterns is just a trick in programming. They call it microarchitecture. You keep wondering, where is the macro? Where is the mini architecture? What happened to them? So it's limited to some code. They call it microarchitecture. There is no way. They don't even know what's the required to do that from two points of view, the function and non-function requirements. It's also stable analysis patterns. This is actually stable design patterns as a system of patterns as well. Stable architecture patterns. We call it system and use on demand. The unified software architecture on demand, US on demand. This would be the core knowledge. Nobody knows how to do that in any system, by the way. So this is very important to learn how to do. So anybody want to challenge this? I'm here, by the way. Fuse is development for the entire life cycle. We're not doing a macro architecture here. We're doing the whole entire life cycle, by the way. Not the way they're doing it, because all the way they do it are disastrous, by the way, all the ways. So capture the development of engine, unified and stable function requirements. Capture the develop the engine's unified, stable, non-function requirements. The existing non-function requirement software is not exist. Is not even, they don't even know it. They don't even execute it by the executable, by the way. So this is more important than a functional requirement, by the way. Develop the ultimate design, which is the ultimate design, unified also. And this is very important because, again, we just doing a design. There is no choice. It depends about whoever working on the system, they choose a design. This is the ultimate design. There is nobody can debate that. Software architecture on demand. Develop an ultimate design and unified software architecture on demand for the engines of the engines. The new and improved next generation solution, by the way. This is brand new. So, Fuse build, this is still an alternative, build on several new innovations, which is actually this innovation exists right now. We have software stability models. We call it now concurrent software development models, CSDM. Fayad, unified and stable linguistic engineering. Because again, the language we use is actually the cornerstone as a domain. The cornerstone is a word, the unified word. So therefore, this is completely different than the people practice linguistics, by the way. Fayad art of abstraction, this is brand new, different algorithm for how to do abstraction. Forget about finding the nouns in the English language. This is nonsense, by the way. This is actually has a lot of innovation. We're also building now unified stable immune testing, which would be running in a system to test everything. They would call it unified SIT. This is all new and development. built in, build on and any common core infrastructures, facilitate on-demand, high reusable architectures, and application with rapid time and open space. To market, start from requirement to the final product delivery. Stop building instance-oriented system. It is a disaster. And reinventing the wheel. This is what happened. So let me explain this. With a system of patterns, what will be the core knowledge? So when I build that engine, is actually built on core knowledge exactly. And I could actually use this engine to generate as many applications as we wish. There is no many different company building machine learning. It doesn't make any sense. They all different. They all also have a lot of crabs in it. I'm telling you as an expert in software engineering. This is really not really this is not a joke. This is really a true problem. It happened over the years. We built system and before, and these systems are gone. They not exist anymore because they're not fitting with this. We're still building the same way the software. Incorporate 24 quality in such as scalability. If anybody tell you the software is scalable, that's a big joke. Adaptable, that's a big, maintainable, no way. And limited reuse and applicability, and many more. 24 non-functional requirement for anything you build as an engine. And they are executable within the engine too, by the way. Stop building instance-oriented systems and reinventing the wheels. Prevent hardware dependencies. We need to do that. This is very important. Of course, the hardware people will not be happy about this. Now, turn all software system into a fuse is a new domain. So this is we're talking about a new domain of knowledge. So we have to generate for this new domain stable machine learning. This is actually as an example. Working on other machine learning like, unified deep learning, data visualization, human rights. We need to have a software human rights like Facebook to be everywhere. Because human rights now has been in the lowest degree of existence, by the way. So every individual we have in the world has the right to human rights, by the way. Software immune testing, unified contract generation. So we could generate contract with pennies, by the way. Any kind of contracts. This is actually building those engines and working on it. This is a project of the future. So for this new domain, we could really do all these activities. And there's going to be a lot of really books we're doing on, for example, for any domain. So stable answers pattern is a book. This is a stable design pattern is a book. Architecture, this is amazing work. Knowledge map for unified software analysis. We don't do domain analysis anymore. This knowledge map is so systematic and is actually follow the guideline for SSM, software stability models. We have to, this is again, by building this knowledge map, I could build a standard for any system right away. And this is going to be a stable standard. It's not going to be require revisions or anything like that because we build based on unified requirements and unified everything, by the way. Now, Fuse as a base book, this is very important. We can, again, how to automate Fuse means how you really build the application on top of it. And actually documentation there is actually you don't have to do documentation. It's already kept within the Fuse. Because again, documentation of an instance means nothing. So when a company, for example, company goes out of business, all the building, all what they have, they become nothing. No value. So therefore, documentation of an instance software is a waste of time. I used to work on system, which documentation would be fill a wall documentation. And the company make a lot of money about this because every page we used to make like really close to more than $70. Believe me, per page. We have thousands of pages, thousands and thousands of pages. So Fuse applicability could really apply as many applications of it. For example, all this company of doing machine learning, they could really build a consortium, build an engine, so they could really be able to build any application they want on top of it, as many applications as they wish. Fuse projects, so this is server. We have several. We have to document those projects because any software you do, you roam one word to as many words you wish is going to be, you could be able to build that software. For example, if you have debate, a software debate, you build a debate with just one patterns, and then anybody can use it for any debates. Any debates, political debates, religious debates, discussion debates, technology debates, stuff like that. So you could build on top of it and you could do it online too, by the way. We have to generate dictionaries, which is similar, different than glossary. Glossary has been built, for instance, this glossary is built for the knowledge of the system. This is a core knowledge of the system, not instance anymore. Instance come and go. Instance are concepts, and there's only two concepts. They actually change over time. Industrial object library, we have to keep this library, and this library could use it to automate application generation. You could really generate as many applications as you wish. So this is actually just an introduction to Fuse. I'm going to start talking about different issues because I have a full course to teach any company and any people about this Fuse thing. This is very important. I will teach them how to do all the stuff there. All what is this list of area, they have to do it, and they have to do it on their own projects. They have to really do this because really we need to avoid reinventing the wheels. We need to avoid hardware dependency. We need to avoid a lot of stuff we're doing, maintenance nightmare. So the idea here, we have to start using this. This is actually based on my experience of more than almost 45 years of how to really build software. This is very important. Thank you for listening. And actually, the last one here, if you have any questions, discussion, please dock comments on it, send me email, communicate with me. I don't mind. I would like to discuss this with you. This is wonderful discoveries and innovations. This is most of the software we do, to be honest with you, is nonsense. Instance means you go into the industrial of cars and truck and stuff like that. We just do an instance of a car or a model. That's it. Thank you for listening.